Hello, my name is Dr. Frank Wong, and I teach at the Oklahoma School of Science and Mathematics. And today's lecture is on Taylor series and the remainder of the Taylor series in preparation for the calculus, advanced placement calculus BC exam. So again, let's see. Dr. Frank Wong, Oklahoma School of Science and Math, and this is preparation for AP Calculus BC exam, and we're going to be talking about Taylor expansions, so Taylor series, sorry. Taylor series and remainder. So this is one of the most difficult things for students to understand. So I'm going to try to give some intuition for what's going on. So let's take a look at some functions here. Let's look at the sine function. Oops. So sine of x, we're going to look at y is equal to a sine of x. And this could be expressed as a Maclaurin series. A Maclaurin series is a Taylor series centered at 0. So the expansion is x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial plus x to the 9th over 9 factorial, and so forth. And so this is called the Maclaurin. The Maclaurin expansion for sine x. And a Maclaurin expansion is a Taylor expansion centered at 0. So Maclaurin expansion is a Taylor expansion centered at 0. So a Maclaurin expansion is a special case of a Taylor expansion. So Maclaurin expansion is a special case of a Taylor expansion. So we can kind of think of this expansion as an infinite polynomial. And the sine function is a transcendental function. Transcendental. So so what we're doing is, oops. So what we are doing is expressing a transcendental function like y is equal to sine x as an infinite polynomial. Okay, let's take a look. Let's take a look graphically at what happens to kind of give you an illustration of what happens here. So I'm going to reduce this over here. Okay. And so, oh, hold on a second. All right, so let's take a look at y is equal to sine x. Y is equal to sine x. So as I mentioned, this is called a transcendental function. Transcendental function. So we have y is equal to sine x. But let's try to build y is equal to sine x from its Maclaurin expansion. So we're going to now do y is equal to x. There's y is equal to x. So you can see that y is equal to x and sine x look completely different. But let's now then add in another term. Y is equal to x minus x cubed divided by 3 factorial. So now we get something that is a cubic function. This is a cubic function here. The blue is a cubic function, and it begins to approximate y is equal to sine x even better. So now let's add in y is equal to x minus x cubed over 3 factorial plus x to the 5th over 5 factorial. So now we get something that even better approximates the sine function, minus x to the 7th over 7 factorial plus, plus x to the 9th over 9 factorial minus x to the 11th over 11 factorial. So we can see that as we add more and more terms, we have a better and better approximation to what the graph of y is equal to sine x looks like. So this Maclaurin expansion, which is x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial plus x to the 9th over 9 factorial minus x to the 11th over 11 factorial. This is the first 1, 2, 3, 4, 5, 6. The first 6 terms of the series. Already we can see that it approximates the sine curve fairly well here, especially between negative pi and pi. All right. So we're going to go back. We're going to go back to our smartboard,